and gentlemen, I do realize there's a queue at the bar, but I'm sure the drink can be served with the silencer on. It'll be fine. Now, normally I would start off by saying my few little words of Welsh, but I'm suffering from heat stroke, so I've forgotten them. So you'll have to forgive me. So you're very welcome. I'm so impressed with all you guys turning out on this extremely scorching day. But obviously you realize what an important topic it is that we're going to cover tonight. So without further ado, I just have Michael Burke, when he's introducing the moral maze, always has a little intro, doesn't he? So I decided to give myself the opportunity to have a small little intro as well. So you'll have to bear with me. So I imagine there's probably nobody here or left on the planet who hasn't heard of the two letters AI, because it's becoming so common in our daily discussions on news, etc. So I was just thinking before coming down about, well, what's my most recent personal experience of using AI? And actually only yesterday I asked ChatGPT for help in how to get past procrastinating over tidying my office. And I have to say, I got a friendly, personal, helpful response with many suggestions and ideas. So then I was thinking about, from a professional life, I'm involved in mental health service, have been for the last 20 years or so, and my field of mental health treatment is actually running scared because of AI. Fearful that AI will soon dominate the mental health space. And after all, why would you pay a therapist a lot of money if an AI therapist is available 24/7 for free or low cost, is empathic, and provides helpful and friendly advice? So then I was thinking, well, what about in the political arena? And only this morning, listening to the news, we're hearing more and more all the time about the loss of jobs, solicitors, accountants, developers. Many more professionals are losing their jobs. And robots are taking over. And on the Today program this morning, they were talking about, in the discussion, about the need to tax robots, because after all, if they're doing the work of the humans, they're going to need to tax them. But here's my favorite of all, on the international political scene. There's a fierce debate sparked by none other than President Javier Milei's radical AI policies. Now, he's in charge of Argentina. I can't say his name properly, I could say Milei. Under Milei's proposals, Argentina is moving to establish the world's first legal framework for AI non-human corporations, which, if he gets his wish, will mean corporate autonomy. So the legislation will allow these AI legal entities to be owned, operated, and run entirely by AI agents and robots, with human involvement being purely optional. They will have limited liability to encourage risk-taking and attract investment. The AI entities would have the same liability protections that shield human entrepreneurs at the moment. And last of all, zero regulation. The administration is pushing for minimal state oversight or red tape to make Buenos Aires the premier destination for global tech and data center investments. So I have no doubt that if these are just some thoughts that are in my mind, that many amongst you will have many thoughts about what this AI business is all about, which we may get into in the discussion. But perhaps what we need now is some help to unpack what this AI revolution is all about. Now, our speaker tonight needs no introduction, and those of you who are regular attenders here will know Andrew Tuersley can be relied upon to ask questions and contribute to the debate. Well, tonight, Andy is up here next to me presenting, and Andy has studied philosophy and music and works in film and graphics programming. He maintains a strong interest in science and the philosophy of science, and is convinced that the image of AI as it is widely presented, perhaps even by me and what I've just said, is misleading. Over to you, Andy. Give him a warm round of applause.
Hello, thank you. So I'm sure a lot of you already have a lot of strong feelings about this thing called AI because, how could you not when it's constantly in the news like this? And, it definitely does raise a lot of like really interesting and serious sort of political, philosophical, and, you know, economic questions. And those are really important. But the thing that struck me is that whenever I talk about anyone like in person, I'm always quite surprised by how little they know about what's actually going on inside it. So, I have my own opinions, but I think before we can actually address any of those big questions, we really need to have like a better sense of what this actually is, and that's what I'm hoping to like give to you today. So, what do you think of when you think of the word AI? You probably picture science fiction, right? You're thinking Asimov, maybe Commander Data from Star Trek, maybe the Terminator. You're thinking like a guy, but better. It's like a person you can talk to, but it's also this like perfectly logical kind of genius. And it inherits the things that we attribute to computers. But there's maybe already a bit of a paradox there because we want it to be these two things that we also think of as kind of like essentially separate. And that's why it becomes this interesting subject matter for fiction. But like this is the sort of language that you hear like a lot of the big AI companies using. Like it's learned everything on the internet. It's a PhD level genius in your pocket. And just one thing I would like to say before getting too much deeper is that this image of AI that we've got, this sort of science fiction thing. If you look there, we've got Mary Shelley's Frankenstein, and then you've got Rossum's Universal Robots. And it's interesting, a lot of the kind of broader sort of existential questions around this subject are actually completely embodied in Frankenstein. But it doesn't really feel science fiction in the same way, does it? It feels more kind of gothic. And it's only in this second picture, which is Rossum's Robots, that we actually get, let me turn that on, that we actually get like the modern word robot, that's where it comes from, and the modern image of the robot. But really, the difference between this and Frankenstein's monster is just that Rossum's robots are being built in a factory and then they're being put to industrial labor. So like clearly what's defining this science fiction image isn't just this kind of like sense of the new horizons of science. It's clearly, got something about like the political tensions of like industrialization in the early 20th century, right? And that continues into how like Alien would depict AI inside a computer in the 70s. So this is how I'm going to try and structure this. First of all, I'm going to like lay out the vague way that it's put together, in the media and in various discourses. Then we're going to cover like some background of like what's going on inside it, and then we're going to put that myth to the test. And it is like a deep like philosophical problem. So we're going to take two approaches. We're going to start like bottom up, like comparing like materially what is this and how does it compare to the brain, and then we're going to like go top down and think what does this do, how does it behave, and how does that compare to the behaviors we're looking for, and then we can finally start to answer some questions. But I hope that I'm not going to tell you what the answer is and that provokes some discussion. So the myth, what am I arguing against? So really it's a bundle of ideas. Some are more fuzzy and some are more formalized, but they generally come together and they're derived from that science fiction image. Firstly, that like in these stories, these models are to be understood in some sense as sort of a creature that lives inside your computer and has its own interests and autonomy and perspective on things. Secondly, it's that they can exhibit what's called artificial general intelligence, which just means that they can do anything that a human can do. And this is the explicit stated goal of OpenAI and Anthropic, etc. Like they're hoping to achieve this so that they can essentially automate knowledge economy work, with the exception of venture capitalist, according to venture capitalist Mark Andreessen. Like apparently that requires more of the human mystery than others. Finally, there are some more extreme claims about AGI naturally leading to something called superintelligence and its various apocalyptic or utopian outcomes. That it will basically get so smart that like we can't even imagine what it can do, and like we can't even stop it. And I've got Clippy here, like to stand for the classic scenario here of the paperclip maximizer, where a super intelligent AI is given the innocuous goal to make as many paperclips as possible. And because it's so smart and can figure out all of the ways of making paperclips and outmaneuver all of the ways we might try to thwart it, it eventually turns the whole world into paperclips, killing us all. I think it's worth noting, though, that like while this is a critique of AI, it's one that the AI industry will regularly allude to and fund. So maybe it's more convenient for people to say that your product is too powerful in the potential future than it is for people to criticize what you're doing in the here and now. And while I'm going to argue against this perspective, I do want to be clear that a part of me is actually quite sympathetic to this. You know, I like Commander Data, and I read all of those Asimov books. And yeah, there is something that can feel a bit sort of knee-jerk and reactionary to dismissing something or what it can do for simply not being human in a way that we recognize. But I just can't help but conclude that this is the wrong reference frame to apply here. That treating this technology as that historical, preconceived, like science fiction notion is its own kind of refusal to engage with the new. And I also want to be clear, I'm going to be telling you about a lot of the things that it can't do, but there are some things that it can do as well. So, before getting too deep into the weeds, I also want to have a quick look at this artificial general intelligence concept and what it is in the first place. I don't want to take it for granted. So an early goal of AI was passing the Turing test, where a machine passes if it convinces you it's a human through written conversation. But it actually turns out that it was quite easy to pass the Turing test. It had been done several times under like different conditions since the 70s, essentially. And the things that could pass it were pretty boring and weren't capable of much else. This is basically because we're social creatures and we love to anthropomorphize anything. So if it talks, then it's like, yeah, it's quite easy to think that that's a person. So AGI emerges as this kind of post hoc band-aid to replace this standard as it lost its meaning. And as I said, basically it means a machine that can do any cognitive task as well as a human. And you can see a little list there what that might include. And the way some commentators discuss it, AGI is essentially synonymous with superintelligence because a human can improve AI, and therefore it can improve itself and then get even better at improving itself until it becomes infinity smart, as though general intelligence, whatever that is the only limiting factor here. This is called strong recursive self-improvement. I think theoretically this is already a bit of an issue for me. Firstly, I don't think general intelligence is one thing. I think it's several things that seem to be interdependent and coinciding with each other. But secondly, there seems to be this bundling of everything that constitutes human cognition, agency, and personhood into intelligence as a catch-all term. I think at best this is intellectually lazy, and at worst like an ego-flattering fantasy of a certain kind of Silicon Valley guy. I don't think that someone with a higher IQ has more subjective experience somehow. And finally, I don't know about you, but I can think of some people with high IQs who aren't necessarily the best at achieving their goals. So overall, I think this notion of AGI as a singular goal to achieve is a bit of a mirage on the horizon. As for whether recursive self-improvement here is possible in an information theoretic sense, I'll cover that later. So, let's see. This is where we are, just keeping you kind of grounded. So, our first shot at a definition. What is AI? This is a rough map of AI proper as the field of study. And you can see that there's a lot going on, and a lot of it is still very much active and has many applications that they're more suited to than others. But I want to, in particular, draw your attention to symbolic AI here. This is like the classic approach where you are kind of like hardwiring in the logic of how you want your thing to respond to stimuli. But like the stuff that you're going to be hearing about in the news is this kind of deep learning square up here. So let's just zoom in to see what we're talking about. And I'm going to explain exactly what this is, but before I do, I want to emphasize just how small a set of technologies occupying a small area within this whole field we're dealing with here. If you ever hear a news story about the scientific possibilities of AI, in protein folding, astrophysics, or whatever, they're talking about all of this bit, right? But whenever you hear Elon Musk, Sam Altman, etc., talking about their investments and getting worried about AGI, they are talking about this little bit here. These are large language models, and you can see that this is the overlap between generative AI and natural language processing. And everything outside of generative AI uses these techniques to tell you statistical features about the data that you might miss, while generative AI uses those statistical features to produce data that looks like the input data. So instead of telling you with 90% certainty that it's looking at a picture of a dog, it will produce a picture of a dog. LLMs are simply that, but trained on text. These are the ones that will react intuitively just to normal language by predicting what the next word in a string of text is going to be. This is why you need to give it a prompt before it starts thinking. The scientists from the first slide are definitely not typing their questions into ChatGPT. I want to emphasize that. They don't need or want AGI, and they have trained their specific models to do specific things with their data sets, because you don't want that vagueness when you're doing science. Those models can be orders of magnitude smaller, so they don't run on massive data centers. So like a lot of the controversial things about this little square doesn't apply to the scientific use cases. So what is this? In contrast to symbolic AI, we're taking inspiration from the brain. This is a nerve cell on the left here. You've got several of these in your brain. And essentially, how this works is it's got inputs at one end, and these will be to other neurons. And then these will build up as neurons higher up the chain fire, and that will build up an action potential in here. And once it passes the threshold, it will fire and then send that signal onto the next neurons down the line. And someone looked at this and thought mathematically this could be quite simple to model, basically. And you can see that's this here. This is just basically you have a number for how much it's going to multiply the signal that it comes in. So that's how much it's listening to each neuron further down the line. And then you can decide what level it's going to activate at. And then you can decide what it's going to send to the next neurons. And then what makes it deep learning, as opposed to other kinds of artificial neural networks, is that it's arranged like this, where you have all of these layers. So instead of them being linked together in particular ways, they are all linked to every neuron in the next layer. And they can just have this kind of simple structure, and then they can make tons of them. And this information, it's also important to note, only flows in one direction. It flows from left to right, and there is no feedback. This is called a feed-forward network. And the reason that this is the way that things are right now is that Google found a very good way of getting them to run on GPUs, which is what NVIDIA make. I'm sure you've heard of those guys. So what is a GPU? On the left, you have a CPU. That's what your normal computer runs on. And you might note it's got a few more complicated parts, whereas the GPU has a lot of simpler parts, right? It's a simpler structure, but there's more of it going on. The CPU is basically very good at complicated things that rely on whatever you've processed before. So like a problem where you need to know the previous answer before you can move on to the next bit. That's called serial computing. That's how most traditional software works. A GPU is good at what we call parallelizable problems, where you can break it down into simple little additions and multiplications that don't rely on what else is going on, and then you can put that information together to figure out what the eventual answer is. These two work in very different tasks, and not every problem can be parallelizable. That's some basic background. Now let's have a look at this bottom-up approach. You can see why this might feel quite exciting, right? We like Commander data, so we want to give him the best shot we can, which means we don't want to attribute anything supernatural to the brain, but we're trying to reproduce whatever it is happening in people, so we can look at the brain and see how it works and compare in terms of structure, systems, mechanisms, how this thing works. And in some sense, between the neurons and the GPUs, this starts to feel quite brain-like, right? And this is what we call bioplausibility. This is how much an AI system resembles the biological systems it's trying to imitate. And the question becomes, not can AI think, but why couldn't it, right? But how does this vague sense of bioplausibility actually stand up to a closer look at the brain itself? In my opinion, pretty poorly. So first of all, these are vaguely inspired by neurons, but they don't actually resemble them much at all. You can see in this image here just how varied neurons can get in connectivity. They're clearly not just going in one direction all the time, and they're clearly doing different jobs by having those different shapes. Secondly, there's a qualitative aspect to nerve signaling. They're not just sending electricity like wires, they're doing it chemically with lots of different chemicals, and those different chemicals all say and do very different things. And even if you do just measure them electrically, they're not just building up an action potential and firing, they oscillate a bunch of different frequencies, and sometimes those oscillations can spread over the brain, and that's what we call a brainwave. And sometimes they cancel each other out. And if you've ever done any work on audio or signals processing or Fourier transforms or whatever, you should have a sense for just how much information can be carried in a bunch of waves, right? And that is totally not captured in the deep neural network. And scientists agree, these networks are not designed to simulate neurons. They do a terrible job at that. They are vaguely inspired by them as a way to perform specific mathematical operations. And I do also just want to point out, if you look at this diagram of the brain here, there are a lot of distinctive structures with each having their own distinct connectivity, and they're each in feedback with themselves and with each other in a very kind of like broad interface surface there. And neuroscientists agree, they can't use these things to simulate real neurons. So finally, following from what I was saying about oscillations, there's a whole missing dimension of the brain's dynamism in time through it here. So the brain, in terms of computer science, is what we call stateful, which means that it's changing internally and will respond differently to the same stimulus when it's in different states, right? And it's constantly, simultaneously processing its output while it's getting all of the input and all of the feedback from itself in real time. And a deep learning network does neither of those things. So to understand why, we need to distinguish between training and inference. Inference is what happens when you're actually using the thing, and that does not affect the actual network itself. Training is how you set all of those weights, all of those numbers in the artificial neuron. It's the process of actually embedding the data in the neural network and filling it with those rates and connections. This is the expensive and power-hungry bit. And this is what they do every time they release a new model. But I want to emphasize that when you're using AI, it can look like it's learning and changing based on your interactions with it, but it's actually not. It's just that the previous chat history you've got with it is stuck on the beginning of the text that it's trying to predict. So it never goes through that process of gradient descent, etc. In order to actually simulate how a brain changes and learns and handles new information, you would essentially need to train one of these big models several times a second for everyone who's using it. And this is a process that takes months and costs billions of dollars. It's also important to note that this is also not an automatic process. It requires human labor at every step, but more on that later. And it is too hot for Guy Deleuze right now, so we're not doing that. Right. So to summarize, that's not closed our case yet. But if you find yourself wondering, like physically, why can't it do brain things, I think like that is my explanation. But all right, does all of this matter if it can actually do the thing? You know, we know that deep neural networks are very good at predefined verifiable tasks, right? So anything where you're giving it a specific kind of data and you can check unambiguously if it got the answer right. This is how the scientific use cases before I was talking about work. But that's a little tricky if we want AGI, because training specializes them. They can't recontextualize or apply what they learn outside of the area where they learn it. But the LLM theory, the large language model theory, is that since we encode thinking into language, thinking and logic, and we have all of these terms like if and because and therefore, that if you make that single purpose that you're training them on, the reproduction of natural language, then generalized reasoning skills will kind of fall out without any kind of qualitative feedback or a world model even. I'm going to say already this is a pretty vague theory of action which runs against the consensus in linguistics and cognitive science. But superficially, the right answer does sometimes come out. And I'm sure you've seen graphs like this all the time of it getting better and better at standardized tests and thinking, hang on, I could take some of these standardized tests and I don't know if I'd get 100% on them. But it's interesting, isn't it? How can something that wins a maths Olympiad fail to do simple multiplication here, right? And I'm sure you've seen all the other things about it failing to count the number of R's in strawberry or telling you to walk to wash your car. This being very good at some things and very bad at other things is called spiky intelligence. And these mistakes are what people call hallucinations here. So the issue is that those tests are standardized. So the model gets trained on tests like them. No matter how good they are, and no matter how good they get at them, it never seems to apply outside of things that resemble the standardized tests. They respond statistically to the pattern of the question with things that look like the pattern of the answer. And they never seem to get past this stage of pattern matching. And those patterns don't contain the underlying logic. So they don't think about how to use that elsewhere. This is what AI researcher Timnit Gebru means when she calls them stochastic parrots in a paper that got her filed through Google. And this you might not be convinced by yet, but it is a very, okay, well, first of all, here's a good example. So a man and a goat are on one side of a river. They have a boat. How do they go across, right? And ChatGPT says the man takes the goat across the river first, leaving the boat on the original side. Then the man returns alone with the boat, then leaves the goat on the other side and takes the boat back to the original side. Finally, he takes the cabbage across the river, right? So you can see it's taken like the shape of this like puzzle of moving like goats and cabbages and chickens or whatever across a river, and then it thinks, oh, this is well, it doesn't. Then it sort of gets pushed into this space where, like, to make something that resembles the right answer, it needs to smash together the concepts in ways that don't make any sense. And each time something like this comes up, an AI company will train it on this specific problem to get rid of it. But that doesn't solve the underlying issue, which is significant because you can't anticipate all of the ways it can be wrong. And if you could, it wouldn't be much use, would it? Because it wouldn't be telling you anything. And I don't want to go through all of these papers demonstrating this time and time again, where people find ways to test it outside of its training parameters. But I do want to mention this one just because it's very funny. Stop anthropomorphizing intermediate tokens as reasoning/thinking traces, ! I don't know how many scientific papers you've read with exclamation marks in the title, but like these people are clearly very frustrated about this being misunderstood, right? So rather than taking you through that, I'm instead going to try and give you like a really intuitive sense for like why this is the case and why it works, and that should hopefully give you a better sense of predicting like when it's going to be good at something and when it's going to be bad at something. So this is going to involve a tiny little bit of maths. I'm really sorry. I did not realize how hot it would be, but I trust it's going to be very simple, I promise. So computers like numbers, right? They don't like words. So how do we represent meaning mathematically? We can start by just giving every word a number, and that's more or less what they do. So you can see here, this is the text, and the numbers are being used to represent those texts. Right. They call these tokens, but there's a bit of a problem. You might want words with similar meanings to be close to each other or have some sort of mathematical relationship to each other. But you also might want some sort of like mathematical relationship between words that negate each other. And you can see like are and aren't, like there's nothing in common between those numbers. And also you can see that like there's no mathematical relationship between this number here, as it is in text, and its representation in the tokens. And that might give you a sense for why it's not very reliable for calculations. So this is a bit of a problem. So if you want to try and encode a little bit more meaning, you might start using more numbers. So you can get a sense that like if you have sort of two columns, you can have like one column kind of representing maybe what type of speech it is. So like you've got the nouns that are kind of up here, and then you might have like the verbs or whatever kind of down here, and then you might have another one that represents sort of like how fruit-like it is, or another one that represents kind of like how positive or negative it is, and then if you start kind of statistically analyzing them to look like that, you will end up like with things where similar concepts like cats and dogs have similar representations. And where like negative concepts might have like one thing in common, but then are completely the opposite in other regards. And there's another good thing about this, which is that one of these lines of numbers, that is called a vector, and that's sounding scary, but I trust you, it's not. It's just a list of numbers. And GPUs love vectors because you can break these down and have them like add up to each other, and it's just doing these simple little addition things, and that tells you very useful geometric stuff. I'm losing you. That sounds scary, but if you've ever used coordinates on a map, you are very familiar with one thing vectors can do, which is represent position. So if you've got a vector of two numbers, you've got two columns. One is going along the bottom, and then another is going along the top. That tells you whereabouts in Asia you are. And then you can just add another column of numbers. And then you can start thinking about 3D space, which would be like how high up you are. So if you start plotting these words, these tokens, in some sort of space, obviously they have like tens of thousands of columns, but the maths works the same. You eventually end up with a shape, and it looks kind of like this. Picture this kind of like a crinkly donut. So if anyone asks you what this talk was about, you were learning about crinkly hyperdonuts, and then they'll exactly know what you mean. But essentially, this is what GPUs are great at, which is geometry. It's a graph problem. And this is an analogy. This is mathematically what it is doing. So what the AI does is use those data points to predict where other data points might be. Like it's fitting a curve to all of those data points there. And then when you put your data in, it's finding whereabouts in the curve that is. Okay? And that might give you a bit more of an intuition for like, what's going on in it. So, for example, it's going to be very good at interpolation, right? Which is where it's already got a lot of data points around it. It's going to be, finding the perfect mean between these, right? But if you're going to be using it to produce anything new, or answer any question that isn't already answered in its data set, it's going to be going off here. And then, I don't know if you you can imagine how curled up this shape is, because it needs to pass through all of the points. And then if it trails off the end, it's going to just go completely nowhere, right? So this is kind of why whenever you get very speculative with these things, it's going to start kind of babbling nonsense and then repeating what you say, because out there, the strongest signal that it's got is your own input. So this also has implications for recursive self-improvement. So we would expect, if these things could recursively self-improve, that the line that it produces when you follow that curve would be just as complicated as the line inside the data points. But it's evidently not, right? And we know that it's not because when you train an AI on AI output, it breaks down. Therefore, it must be, on its own terms, there must be an intrinsic difference between thoughts produced by AI and thoughts produced by humans. AI-generated data poisons it, human-generated data doesn't. Because we have empirical experience, but also because we can reason, and also because we have experience of whatever else might be going on there. So therefore, no, it cannot self-improve. It cannot learn from itself. All of its improvement is driven by data we produce that is running out of. And it can't even sort that data by itself, okay? If you do that, it ends up basically oversampling and then Yeah, I'm not going to go into that. But this is a basic information theoretic problem. In order to tag and contextualize all that data and to keep these models safe and clean from all the horrible stuff on the internet, you need humans. Thousands and thousands of humans, typically in the developing world, doing menial, often traumatizing work for about $2 an hour. I actually did some of this over COVID, and I can tell you it's rough. So, it also shows why it's dangerous to rely on its judgment. There is no internal qualitative or structural distinction in that shape between examples of truth and examples of falsehood, between good reasoning and bad reasoning, between speculation and fact, and even between your input and the output in its prompt history. It's all just points on that line. All the data is homogenized, and it's just simply not what this architecture is designed to do and not what it is capable of doing. So can an LLM advise? When you ask ChatGPT, I mean, personally, I wouldn't because, I kind of want to see, like, how the, the mental health stuff shakes out. And also, like, I don't really want to support this industry very much. But, like, setting all that aside, a rule of thumb would be, do I think most of the people talking about this on the internet are likely to be correct? So for anything definitive and specific but time-consuming to research, like a grammatical rule in a language that you're studying, then it's great. If it's something like, maybe contentious, then it's not useful. I think the best you can hope for is going to be just like a summary of the contention. But like if you're trying to like get it to check your reasoning, it's going to inevitably like agree with you. And anything actively speculative, that's just a great way to give yourself psychosis. Right, I'm not going to do embodied condition. This is really fun. Well, no, this is actually really annoying, but I'm also going to skip that. If you want to talk about it, we'll do that afterwards in the discussion. Can it create? So there's this notion that all art is a remix, right? That we're just combining together all of our influences in different ways that have already existed. And for me, one upside of AI is that it made me realize how like creative this is in contrast to what AI does. Because when we do this, we are not just thinking about the AI, about the influence as it exists as a text. We're thinking about our own personal relationship to it and our bodily experience of it. And then that makes our own kind of what we're combining particular to us. So like when we do combine these two terms, it ends up in a new direction. Whenever an AI does the same thing, it can only end up as like the exact mean in the middle. So therefore, it's always going to produce the most obvious combination of those two ideas possible. And I think if anyone does use this artistically, really, really just try and do something yourself, even if it's going to like feel imperfect or whatever. That's going to be the thing that makes it art. And like all of this stuff is just I don't know. Among my generation, at least, it's very unpopular. It's considered like extremely ugly and crass and kitsch. Then we come to programming. Now, this is the strongest case that these companies have for big LLMs having like commercial viability. And the answer is sort of, yeah. So a lot of programming problems are basically about combining ideas that are already well documented. And it's pretty good at this, but it's also like, because it's not reasoning, if you look at any code produced by a large language model, it's not very, it's absolutely unmaintainable. And this is a graph of like the amount of code submitted by Anthropic employees, suggesting that, oh yeah, we're submitting, 8,000 lines of code per quarter. And this is per person per quarter. This is a good thing. This shows how productive we are. If you work in software, that should horrify you, because like the value you're producing as a software engineer isn't code. It is maintaining code. And inside of all of this is like spaghetti. It doesn't like connect together. It just kind of works for the time being until several months down the line, you try and change it, and then something breaks, and then you've got a very expensive problem on your hand. But it is very good at these specific verifiable tasks. And surprise, surprise, these tend to be the boring ones. So maybe instead of trying to get this thing that isn't a brain and doesn't do what a brain does to replace brains, we should use it as a tool for what it can do. So here's one model that I'm quite excited by. This is one that takes green screen footage and removes the color key from it, which you've never tried, but I promise you it's not creative, and it's just the biggest pain in the bum that you've ever done. But yeah, I'm very glad that exists. There's also this down here, which is an upscaler, and note again that you've got this kind of regular style interface with it, right? It's not like typing in make this do this. You are kind of you have control over the parameters. And finally, there is all of the medical applications, and these are great. But I will say that protein folding and finding a new drug isn't the actual bottleneck there. That's the bit that AI can help with. But the real bottleneck in getting medicines to market is testing, because you don't know how it's going to move through the body. You don't know what else it's going to do on its way there, and all of that. So finally, some answers. What is AI? Sorry. I think this is the one that I'm going to land with. It is fuzzy data retrieval. It's a way of compressing semantic information. So if you imagine you've got a big photo of all of the internet, AI basically squishes it down like a JPEG. So it makes it more manageable, more searchable, and it also means that, if you remember traditionally, you had to search in Google, you had to use the exact word that showed up on the page. With this, you can get sort of the right word and then get sort of the right answer. I think that's a pretty good way to think about it. But also, you can note that sometimes you're going to be searching something that's gray, and it's going to say, oh, there's something green there, and that's just the nature of it. Right, we can get past that. Okay, but then, personally, I'm a little bit pessimistic about it. I'm especially pessimistic about what these big companies are trying. I can't give you financial advice, but you make your own judgment calls there. Thank you.
So, as my father used to say, I don't know where it's all going to end.
Sorry.
And I'm going to take the opportunity as chair to get in with my first question before we turn it over to the floor. Is that okay? So, Andy, as you listen to the things I pointed out at the beginning, the sort of personal things, local political things, particularly the one about your man down in Argentina, do you think, have you got some comfort from what you believe is your sort of better understanding of what these models are all about and how it gets created? Are you, when you hear this news about the risk of sort of robotic taking over of corporations and all of that,
so I mean,
how do you interact with that?
I get some discomfort because I know that for one thing, if it's done naively, then it's going to crash and burn. You've seen people using AI agents to just drive their computers, and it's dangerous not because the computer is going to turn evil and take over the world. It's dangerous because you're putting your email address and password into unpredictable buggy software, which is just never a good idea, and then connecting that to the internet. And people have lost a lot of Bitcoin money doing that kind of thing. And similarly with Milei in Argentina, he doesn't understand what he's talking about. He can write the law, and then people might try. I doubt anyone's going to actually try and set up these things in exactly the way that it's being imagined there, but I imagine, people might try and take advantage of that law, and it'll probably be some kind of shell for some kind of dodgy dealing. So I'm not very comforted until the market becomes rational, essentially.
Great, thank you. Okay, so let's open it up to the floor and let's hear what people have to say and think and comments or questions. We've got down here at the back.
Andrew, thank you for that. Thank you for the talk. I think a lot of it went over my head.
Sorry.
Never.
What I'd like to ask you is, you referenced your generation and your feeling about AI.
Yeah.
I was having a conversation in a meeting yesterday about how AI can deal with tasks that people early in their careers would learn from.
Mhm.
And yet, if their jobs are taken away and all those tasks are done by AI, where do they get the full understanding? And I sort of compared it with the calculator. When I did A-level maths, I had to use a slide rule and logarithm tables. Then the calculator came in, and everyone put all the numbers into the calculator. The calculator gave an answer, but very soon, no one could actually rationalize whether that was the right answer.
Mm.
They just believed it because the calculator said it. And could the same be true for AI?
I think so, absolutely, and I think it's I would possibly make an argument that because they are trying to generalize it, that AI is a little bit more troubling because the things that you learn early in your career are like things that like define how like the more advanced stuff that you learn and how you understand that. Whereas like it's you can make the judgment call. Do you want to be skilled at this thing, or is this something that you're happy kind of like having in a kind of completely instrumentalizable way? But like as for like young people coming into the workforce, in terms of coding, people are getting worse at coding, and then there's also questions about okay, if all of the entry-level jobs are going, then like how is anyone going to get employed? But it also extends outside of the world of work. Like every case where like people have been like bringing AI into it, it just comes with de-skilling even of like people who formerly were skilled. So the doctors who are using it to help like diagnose X-rays, for example, suddenly find that they're not very good at diagnosing X-rays. So yeah, I think that's a concern. Yeah.
Over here, Mark. John.
Thanks, Andy. That was really interesting.
Thank you.
I suppose one of the things that you explained a lot, and a lot of it went over my head as well.
Just hold the
oh,
mic
yeah.
a little closer, please, John.
A lot of it went over my head as well.
Mm.
But you explained a lot in terms of sort of logical processes.
Mm.
And yet increasingly we're sort of beginning to hear about people turning to AI for emotional support.
Mm.
And you hear about girlfriends, boyfriends, etc. How is that logical framework feeding into an emotional feedback loop that can then encourage people to have relationships with an AI model?
Mm. So I mean, part of my point is that it isn't really. It's a logical framework on one level, but like on the level that we engage with it, of like saying giving it logic problems and then it gives us like gobbledygooking out. It's not actually logical. It's just sort of pattern matching. So I think it's kind of it's actually much better at kind of. It's no, I don't want to say it's better because I think it's quite dangerous actually. But like it's the reason that I would go to Bill rather than go to ChatGPT for my therapy is exactly what I was saying about like using it for like speculation. In that like if you're it's going to be a terrible therapist because it's just going to like reinforce everything that you already think. And like not offer you any kind of checks and balances. And I think that's really addictive actually. I think that's the closest thing to an actual, like I don't think it can happen on a consumer level. Like I don't think AI boyfriends and girlfriends are going to be enough to like keep this going. But it might be that, the coders who are getting addicted to this are, enough to paralyze companies such that they need to keep on taking in the AI. But like I will say, I didn't like I skipped over it a little bit, but companies are noticing that like the margins, like the return on investment for AI is like negligible or like it's impossible to measure, but it seems pretty low. And this is while all of this stuff is heavily subsidized. All of these companies are, not making a profit. They're like every year, raising billions of dollars with from like Saudi oil funds, basically. So yeah. Anyway. went
I
off
was,
of it.
I was very pleased to see that Elon Musk had dropped down below the trillion mark
Yeah.
because AI had dropped.
Oh, Mark. Oh, sorry. Here and then over here. Okay.
Thank you, Anne. Can you hear me?
Yeah. Ooh.
Yeah. That close?
Down.
Oh,
Again.
Yeah.
that close.
Oh, but
All
yeah.
right. Okay, and thanks for that. And I realise your brain probably works about 10 times the speed of mine. But I have very limited experience. That's why I came along to try and learn some more. But my personal experience was a granddaughter who was going to Central America,
Mhm.
and she was going to about 8 or 9 countries. She was staying with me, and I said, have you done research into them? And she said, no, not yet. And I was thinking, well, it's getting a bit close. And I'm thinking of all the lonely planets and rough guides I toted around the world. And the next thing, she produced this amazing document of, I know she had to put in how long she was going to each country and that. She's very allergic to nuts, she put that in. And the document she produced in a very short time was so impressive. That I thought that was a great use of it. So I think there are some super uses of it.
Yeah, yeah. So I mean, I think that's a good example of it as like a kind of search, right? Where like it's compressing all this information down, and yeah, it is good. It depends on what you're doing the research for. So like if you're just getting a sense of these different places, and you would just be relying on what people are saying online anyway, then yeah, absolutely. But if you are using it, for example, if you are one of these law companies that tries to use AI to like do the casework, there's one example of someone who used AI to produce a document, in a legal process, and then only to discover that it had made up all of the references and all of the case history. But like, I do think that like, in some sense, that kind of work could be facilitated by this, because that's another kind of like menial, painful, boring thing. And you could ask it to maybe, give us a list and summary of cases that are relevant to this, and then check to make sure they exist and that they actually say what it's saying they say. But like in terms of the initial research, yeah, that can be a really powerful tool to like, mean that you don't have to like do all of that manually. You've got a direction to go in. I can see that possibly being useful, yeah.
Mark over here. Yes.
Thanks very much. Very.
I don't know if that mic is working very well.
Yes.
Can you hear me?
Yeah.
Yeah, I'm doing it right. Yeah. Okay. Thanks. I just wanted to pursue. Can you pursue this question of give us a better sense of the skepticism in your peer groups, your generation, or however one wants to put that? I mean, is this crystallizing into something in terms of, embryonically a social movement or something of that sort? I mean, we're seeing pushbacks against data centers, for example, in the States, for environmental reasons and so on. And some of these limitations that you're highlighting and the errors and the mishaps, but also more fundamentally, the impacts on our own cognition and our own understanding of our cognition, perverse impacts. I would expect to see increasingly a social reaction against this. And I'd just be interested in your thoughts on that.
So among my peers and people my age, I think I do notice this social reaction. But then the question is like, how can that actually translate into like some kind of real change? And unfortunately, because this is all like this is all kind of like financialized, and this is all happening like at a loss on the hopes that it's like the next social media or whatever. like there isn't any kind of market pressure there. There's also, like I say, I know people kind of my age are really put off by it, but people a lot younger don't kind of have the context to like know anything different. And if this is their first way of like experiencing, reading or research or like creating art or whatever, they just get like the addiction. So I don't know.
Sorry, can you just make it distinction? We're all fairly old.
Oh yeah, sir.
We're all fairly old. We this distinction between your generation and this generation below yours. Give us some age.
It's so I would say sort of like 20 to 35. Everyone is really not happy with this unless they are in the financial sector, because they're being paid a lot of money to be happy about it. But I think like Gen Alpha, like the generation after Gen Z, they I don't know, I don't know any of them, but they're they don't seem to have that same response necessarily, or if they do, it's kind of like imitating it, but they're also using it, kind of thing.
I might have a bit of a long question, but just to build on what you were saying then about people our age, the social movement is really difficult because it's tech bros and tech billionaires, and money sort of quashes all of the movements right now. So on social media, people disengage with anything that's generative AI, but they tend to not care, the tech bros in Silicon Valley. They just plow it. Spotify, for example, has turned down the option to get rid of any artificial intelligence music. They just don't care. So the movements feel inadequate right now. However, I'm a musician, so I keep up with that side of it a bit more. And Berklee College of Music put on, which is one of the most prestigious contemporary music schools in the world, put on a course that was a songwriting AI course, and every student who would be about 18, I guess, every student who was on that course boycotted it and protested it and got it taken off the syllabus. So there is some pushback, but how meaningful that is, I don't really know. But what I was going to ask you, Andy, was, so like I say, the tech bros are behind this, and all the money, and wherever you go, AI is the next big thing. And if you think back about 5 to 10 years ago, crypto was the next big thing. And there was crypto everywhere, and money's not going to exist anymore. And now, no offense to anyone who's got crypto in this room, but I don't know anybody who uses crypto, and the people who seem to shout about it online seem to be sidelined in that community when it was going to be the next social media.
Yeah.
I would say since the internet, the social media has been the biggest change. So there was the internet that changed everything. Social media changed everything. Crypto was going to, and it didn't. And there's been a few other little things. Now AI is going to change everything. How likely, based on your sort of deeper knowledge of how it works, how likely is it that the bubble will burst for the tech bros and it will become just using it for menial tasks, planning holidays and things like that? Or how likely is it that, if you read the news, it's the most important thing in our, in our existence, and it's going to be fused with robots and robotics, and it's going to put, robots with brains and all that sort of stuff. Where do you see it ending up?
Again, I can't give financial advice, but like the premise of all of these businesses is that they are convincing all of the people who have like melted their brains with money that like it's going to get this AGI thing, which doesn't exist, or like definitely won't be an output of making these things bigger and bigger and bigger, because that's essentially what's appealing about these massive neural networks and about like the fact that you can just put a load of GPUs together because they're powerful and make a because they're parallel, sorry, and make a bigger GPU. It's just that you don't need to really research. You don't really need to engage with anything kind of like new or that might kind of change the direction or whatever. You can just like pour money in the hole and then hope that eventually you're going to get the thing that you want, which is ideal for these kinds of people. But like it's not going to work. And so at some point there will be some kind of bump. I don't want to say exactly what the outcomes of that will be. I know that like a lot of companies are going to lose a lot of money, and I know that given the way that these IPOs have gone, a lot of our pensions, for example, are going to be highly exposed to that. So that's another reason that I'm not entirely comforted. The future. So when you say putting AI in bodies, I actually had a slide about that. That I got rid of because one of the things that AI is missing is this like bodily experience, and like it's a more and more popular idea in cognitive science that the body, not just the brain like in a jar, the body has a lot to do with cognition. In a way that we've been neglecting for a while. So I do think like one of the more, if you were trying to produce this sort of science fiction creature thing, I think the direction that you would study would be, trying to give these things bodies and make them react to it. But in order to make that work, you end up having to basically build one something as complicated as a brain. You can't just like have a massive LLM, and that's setting aside all the questions about time. Like you can't be constantly like training the LLM. So like this, if we want to be like as positive as possible, this was a kind of like interesting step forward that might be a part of a larger puzzle. But like it's also probably going to need to change a lot in order to be part of that puzzle. But in terms of, sorry, there was an earlier part to your question that I forgot.
It was just about, will this bubble burst and we just end up using AI to plan our holidays rather than it being used for warfare and...
So unfortunately, I think, I think the business-to-business applications aren't going to work. I think the consumer applications generally aren't going to work because, like, when you're planning your holiday, you're still using this heavily subsidized kind of model, right? So, like, once they actually start charging what it actually costs to do that compute, that might not necessarily be accessible anymore. But the military-industrial complex has a lot of money, so I don't think they necessarily care if they get the right answer, right? This could be very useful, not necessarily for doing anything new, but for distributing the blame for who decided to like bomb the Iranian like girls' school, right? In fact, that was actually an example of a decision made with AI. And like also surveillance. I think there's a lot of data. It's hard to kind of move through, and like for a while that made me feel kind of comfortable. Like who's going to be snooping on me? Like even if they've got this data, who cares? But this makes that sort of easier to navigate in a way. And finally, you did see those news articles about Claude Mythos exposing all of these software vulnerabilities. I think that's so a lot of the big news stories about AI, I would say, it's completely misleading. It's not like correct. I think that is something that it could actually do, and it does need to be that big for. But it can't write secure code, which again, that doesn't mean that it can do all the other stuff. But if it can waste a lot of money finding like the one vulnerability that everyone else thought was safe, I mean, that's the kind of thing that the U.S. military they love to waste a lot of money doing. So like. The hope is that the bubble bursts like on Trump's watch, and then he doesn't know what's going on enough to like take advantage of it. For me, at least. And like in terms of what you were saying about like money kind of like rolling over social movements, I might want to bring your attention back to the paperclip maximizer, where like you get something that's really good at making this one thing so good that it destroys everything else. Like maybe there already is a system that does that, and maybe it doesn't need to run on GPUs. But
Let's
Okay. Thanks, Andrew. Well, I'm in a different position in the conversation that you've kind of orientated, and I'm in agreement with, most of the, illusions and what would you call the way that things are comprehended around intelligence and the nature of thought, cognition, reason, logic, whatever. Originally, I'm a cognitive neuroscientist, so I've been through many models, but I still feel you was using certain pictures of the human being, which in some ways, I think LLMs help us focus on what the human being may be. You did it with the embodied cognition notion. But the idea of a person rather than a brain, I think, is where I would begin a genuine sense of where the textual LLM fits into how we think and talk, because that's where it is seductive.
Yeah.
I think that's what kind of my first kind of proviso of the image of a person becomes stronger, as you mentioned and as the musician mentioned. What does it even mean to do a creative act as a human being? Which I think would be a stronger place than the retreat to the brain and cognition. But not that I'm against what you did, but that's just where a kind of placement of how we orientate around AI, which I think I've hated AI ever since I've had to learn it back in the 70s. And so LLMs is a much more interesting feature, I think. And I think you highlighted that quite well. But I'm a fan of what they do, even though I have to work out, is this journal article completely generated? So I think, in a way, the horse has bolted. Academia is full of students just producing stuff that's really hard to detect and that is quite convincing. And then you have to get ChatGPT to work out, is this AI? So I'm trying to get at here, I see this as a great thing because it forces what does it mean to live as a human being. The reading feature, because when you read it, it's seductive. So I've used it quite extensively, and you have to learn how to use it. So I'm with Turing. You've got to learn how to use these tools by doing them repeatedly, and then it forces us as human beings to take control of the power. So that's where I come from, was I felt you were resisting the flood, as you say, 17-year-olds, 18-year-olds, they produce convincing stuff. And at that point, there's such a flood. It's better than Google or Alta Vista or the earlier things that we're searching. So I think that's where I'd orientate on a more kind of productive motion of how we kind of engage with what it actually does to human beings. So I talk about the reading mind, and there's something that doesn't read. And we've been reading as an educational system for 8,000 years, and we write things down, and so force us into there's other things that can go on in face-to-face encounters, in conversation, that can't be predicted, the spontaneity. So I think that's all I would try and... What it does do is it shows us where a conversation can go in a different direction than simply, the way the words work. So I do think we have to use them, because then it might be, if you don't use it, then it becomes something that takes over in certain arenas, and you're just not in the conversation. That's all I wanted to kind of.
So there was a lot kind of in that question, but I would push back a little bit against this notion that because it homogenizes when you use it, it homogenizes a lot of speech. So I know a lot of teachers who I personally know when something has been written by AI because there's a very recognizable cadence, right? It really loves the contrastive structures. It obviously loves the end dashes, but you can tell it to get rid of that, but it's still got the kind of yeah, but it's still. Yeah. I know. I'm just saying, when people get really into LLMs, they tend to go into a little LLM area that isn't really in conversation with where I think the actual interest in the power is, which is in organizing people. But
This sounds like
Sorry,
something to be taken into the conversation
sorry.
after.
Yeah.
There's just another question at the back.
Hi,
or
sorry.
comment at the back.
Hi, and thank you for the talk. It's been very interesting. The bit I understood of it. I'm trying in my head to summarise it, and I think we're around. There's a Jimmy Carr line about how AI is basically a tribute band.
Yeah.
Yeah, and so going back to Alex's musical analogy.
I wish you told me that, and then I could have not written all that.
It's a tribute act, and Paul McCartney's not afraid of the bootleg Beatles.
Yeah.
Which sort of summarises quite a lot of it quite neatly, I think. And I guess the debate is whether AI can ever become creative in that way, and you clearly don't think it can. And I hope it can't, because I think that's the role. With all computer science we've had, it's about raising the level at which human beings can work. Get the grunt work done by a machine, and then human beings kick in at a higher level. And I've just heard a scientist, I think, justifying art, which is a lovely thing.
I want to be like I'm actually an artist.
Good. Excellent.
This is my hobby.
But as an industry, they're justifying art.
Yeah. Oh, right. Yeah. No, absolutely. That's one thing that I liked about it.
The other thing I'd say is that I think you're right that the big problem at the moment is how they're going to monetize AI.
Yeah.
It's at the moment they're giving it all out for free. We're all going on using ChatGPT. We're not paying a penny for it. And the big question is, will we have an economic crash because they can't find a way to monetize AI?
But I do want to push back a little bit on or not push back on, but like sort of clarify. You say that like I don't think that AI can ever produce art. Like I think possibly it can. But like AI in the sense of like the big kind of picture of like the entire this thing, right? Where like it's going to involve all of these different complicated pieces coming together, possibly in a kind of embodied experience with like much more advanced technology, to then sort of like, you know, have a particular point of view and then a particular embodied experience, and then that thing could produce a kind of art, but then like it wouldn't be sort of threatening. It would be like the kind of interesting, beautiful, speculative thing, because it's, you know, producing art that makes sense to it, and then that's like an other that you can like interact with artistically and like learn from and all of that.
Yeah, there's a lot of music on YouTube where people have, you know, asked AI to produce an ABBA song in the style of B.B. King. It's fascinating the first time you hear it, but then you realise it's not actually that creative.
Yeah.
John.
Yeah, thanks for the talk. Absolutely fascinating. Comment rather than question. It's a new technology.
Yeah.
New technologies always scare people. The Jacquard loom came in and put thousands and thousands of weavers out of work.
Yeah.
No, it didn't. Actually, what happened was large amounts of cloth was made with more varying patterns, and it was done on an industrial scale.
Okay.
It took time to get that going. So it isn't necessarily a bad thing that these things are moving on, but the Jacquard loom hasn't survived as a technology because things moved on from it. That's just the one comment. The other comment is, I've used the ChatGPT and Grok and things, and I've found that the best thing to do when you ask it this question is you must know the answer, because what you end up getting is a load of bollocks.
Yeah.
For instance, you ask the GPT who invented the GLS lamp, electric light bulb, and it always comes up with Edison, every time. And we know that because it goes out and it's just a consensus engine. It looks at every single paper that's been produced for the last 100 years, and there's a large amount that says Edison was the one. But it wasn't. It was a guy called Lindsay,
he was in 1835, some 40 years before Edison, and Edison didn't in fact invent the light bulb. He bought somebody else's patent. So it comes out and it says it absolutely, it was Edison.
Yeah.
Then you say, what did Lindsay produce in 1835 in Dundee? This was the first light bulb.
Yeah.
Then you go back to it and say, right, you've just told me that it was Edison, but you've now told me which one is correct. And it gets his knickers in a twist.
Yeah.
And comes up with loads of other people, and eventually will agree that it was Lindsay and it wasn't Edison. So you then ask it, as you were wrong initially, will you now correct your memory bank? And it says yes.
Oh, it physically can't.
This is what it says.
I know.
And then you ask it 2 days later, and guess what? It's Edison's back again. And this is the problem, is everybody's going on and they're just believing what they're seeing. That's history, and we know history, and we have empirical evidence, so we can show that the machine learning is not learning. It's just regurgitating falsehoods. And I'm with Andy there. I think it's going to be a great problem. I'm sure it can be fixed. How they want to fix it is another thing.
So like there's a couple of things that I completely agree with you, and I hope that I mean it probably didn't help, but like I hope the idea of like interpolation versus extrapolation kind of like explains sort of like why it ends up like just producing the average kind of response there. I completely agree, and I'd also like to add that that story of Edison is also quite similar to the story of Elon Musk in terms of his supposed engineering genius. Yeah.
Thanks, John. We've got another comment.
Hi, Andrew. Thanks very much for that. That talk was actually incredible, I think.
Thank you.
I think it was magnificently researched, and I've learned an awful lot from it. I think you'd be proud of it, actually. Your conclusion, however, I slightly deviate from. If you look at, if this was a meeting 200 years ago, it might have been a farmers' meeting worrying about the advance of the tractor. And over our lifetimes, we've seen a lot of technological progress, from the internet to computerization itself, and this is just another one. We use it in our business, and it's just another thing that's come down the track. We use it extensively now, and there's no point in denying it. Everybody's just got to embrace this. It's no point in saying we shouldn't be doing this and it won't happen and this isn't wrong. It will only get better. You point out the failings on it, but it's only going to get better from this point onwards. And everybody should really get their head around this and think, right, well, this is where we are now. This is where we're going with it. And I think even young people should be doing the same thing as well. And it won't go away. I don't think. That's my point.
So I mean, this kind of relates to the Jacquard loom example, and like I think there is some truth there, but like also with the tractor and with the Jacquard loom, like you got either of those and you suddenly start making more money, and that is just not the case with this so far, right? And that's like the anxiety about like some kind of like bubble or something happening for me. But in terms of I agree. Like it will continue in some. If I imagine what it will look like in the future, we'll probably have smaller local models like the Chinese ones, like DeepSeek or whatever, which you can like run on your own computer rather than paying for compute from a massive data center, and like I think the sort of like way of like getting your head around it is precisely to disabuse yourself of the way that the big AI companies are talking about it, and then find ways of like using it to research your legal case or your holiday or whatever. But like it's not going to be big data centers because
Okay. Well, look, with that, I think we've been at this for quite a while now. No, that's absolutely great. but we're all probably stuck to our seats. Time to get up and shake ourselves out a bit before those of us who are having dinner here. So could I ask you to put your hands together for a warm round of applause for Andrew? Well done. And thank you to all those who asked questions and added comment as well. It was a very interesting discussion. Thank you. Any announcements, Mark?
So I'm just going to go and check about the food, so please get yourself a cool drink.